Good evening, everyone, and welcome to the second session of the IEEE CodeX Sri Lanka Session Series. It's great to see you all here with us again. Whether you've been with us since the awareness session or are joining today for the first time, you are now a part of a growing community. You are part of CodeX. I'm Yashoda De Silva, your moderator for today's session, representing the CodeX Sri Lanka team. I'm excited to guide you through another valuable session in your journey towards becoming a better coder. Now, before we dive in, let's quickly revisit what we did last week. Last week, we officially began our learning journey with the first session of the CodeX series, led by Mr. Lakshit Nishankar. In that session, we explored the fundamentals of competitive programming and time-space complexity, setting the stage for everything that follows. The feedback was overwhelmingly positive, and the engagement level showed us that this community is ready to grow and go far together. As we move on to today's session, and before we begin, a quick reminder to everyone. As you all know, certificates of participation will be awarded at the end of the CodeX Session Series based on attendance and engagement. To support this, please make sure your Zoom name matches the name you used during the registration. I repeat, please make sure your Zoom name matches the name you used during the registration. This helps us track participation accurately. Thank you for your cooperation, and now we are moving on to today's topic. Tonight's session will cover two-pointer techniques, arrays, and prefix sums, three essential techniques that appear frequently in contests and interviews. Mastering these will give you a major edge in solving problems efficiently. To guide us through today's topic, we are honored to welcome Mr. Apiram Rajamohan. He is a passionate and accomplished competitive programmer, having secured second place in Sri Lanka at IEEEXtreme 17.0. With years of experience in algorithmic problem solving, he has consistently excelled in both national and international programming contests. Please join me in warmly welcoming Mr. Apiram Rajamohan to CodeX Sri Lanka. We are truly honored to have you with us, and we are looking forward to an engaging and educational session. Over to you.
Thank you, Yashoda. So, hi guys, I'm Apiram Rajamohan. I've been doing competitive programming since 2020 and been participated in many competitions throughout the year. Do you guys want me to share my screen? I mean, share my video? Do anyone want me to share my video?
Mr. Apiram, if it's okay with you to share the video, I think it's better so that we can improve the engagement here throughout the session.
Okay. Since Yashoda wants it, I'll share. Hi. Let me share my screen. Okay, hope you can see my screen. Can you see my screen? Hello?
Yes, Mr. Apiram, your screen is visible.
Okay, nice. So today what we are going to see is two pointers and prefix sum. Since, I mean, it's not a major algorithm, but it's quite useful and come in handy when you solve problems and all. So let's dive into it. Okay. So, what is two pointer? It is exactly what the name suggests. We are going to keep two pointers somewhere between array or string, so we can solve some set of problems using that. So, maybe in general way, we use two for loops, right? In those kind of situations, we can use for some problems we can use two pointers to, instead of doing two loops, we can do the thing in one loop, and it will reduce the time complexity from O n squared to O n. So yeah, so that is what exactly two point is. So there are several variations for two pointers. By the way, if you guys have any question, please raise your hand during the session. It's fine. I can answer whenever you want. So yeah, so there are different kinds of variation for the two pointers. So first one is opposite directional pointers. Okay, so let's look at this problem. You're given an array with all the elements in ascending order. And the problem is you had to find two uh, two element where the sum equal to x. They given a x, and you had to find two elements where the sum equal to x. So for that, what you can do like use two for loops and maybe name it as I and j and iterate and check whether the sum is equal to x or not. In worst case scenario, there might not be two elements which satisfy the condition, right? So in the worst case, it will go to O n squared, even though if you break the loop when you find an answer. So in that situation, what you can actually do is you can mimic those two for loops in one loop. Like um, you can have a left pointer and right pointer. Uh, let's say like you start one pointer from the beginning and one point from the end. And if the sum is greater than the given x, you can move the right pointer backward, because like the right point is what like if you move the left pointer, the sum will be bigger than the previous one, right? So you can move the right pointer behind. If the sum is less than x, then you can move the left pointer forward. So at finally, if there's like some pair which satisfy the condition, you can find it out. So why it is ON instead of ON squared? Maybe you can argue like both point, like it's kind of doing the same exact thing as two for loops. But here, one thing you can notice is like the left point. What are the points that left pointer can be in, and what are the how many number of points the right pointer can be in? Both can be in different points. So at most there will be two n moves going over there, and maybe you learned about time complexity in your last session. So if you generalize it, it will come to ON. So yeah, that is exactly opposite direction pointers. The other one is sliding window pointers. Actually, this is the most used, and yeah, this is what exactly define the two pointers, because like using this, you can solve any kind of two-pointer related problems. Yeah, let's look at it at the last. The other one is fast and slow pointer. Actually, this is the most rarest variation that can be seen across problems. Yeah, like I solved nearly like thousands, maybe 2,000, 3,000 problems, but like I seen this variation maybe like 10 or 15 times, but it's very advanced. If you think like if you uh, understand this thing uh, correctly, then it can be very, very useful. So let me give you a simple idea what is fast and slow pointer is. So have you guys heard about Zoid cycle finding algorithm? Maybe tortoise and rabbit algorithm? Have anyone heard about it? Guys, you can talk. I hope not. So there's a algorithm to find cycle. A simple algorithm using two-pointer variation to find cycle. So it's for tortoise and rabbit algorithm. What it does is it will have two pointers, like one called as slow pointer and one called as fast pointer. So what it does is the fast pointer move uh, two steps ahead, and the slow pointer moves one step ahead. Uh, let's say there's a cycle. So after K move come to the same position. Okay. Sorry. So if there's a cycle of length K, uh, after K number of moves, both pointer will come to the same exact point. If that if both pointers are in one exact point, then you can say there's a cycle, because like otherwise both point won't get into same point, right? And if you think further about this fast and slow pointer, um, it like it can be very advanced. Like maybe you can think, instead of moving like uh, two steps ahead, maybe um, why can't I move like uh, k number of steps ahead, like 15 steps ahead? So like based on the problem, like you can adjust how many steps the fast pointer needs to move, how many steps the slow pointer needs to move, kind of thing. Maybe like in next section, we'll do some problems related to this as well, so you can understand it more clearly. So the next one, sliding window pointers. So what it does is like we will have left pointer and right pointer at the beginning. Maybe yeah, I added some 3 point problems related to that. Okay, let's look at it through some problems. So you have to find largest segment with sum less than or equal to given s. Okay, so if, uh, let's assign both uh, left pointer and right pointer to 0, and move both the pointers until it satisfies the condition. For example, okay, here in the problem, you can move the right pointer until the sum is less than or equal to x. If the sum is greater than x, then you have to move the right pointer likewise. So after doing that, you can say like uh, the segment contains the sum less than or equal to s, and you can get the maximum. The next problem is like you have to find a smaller segment with sum greater than or equal to s. It is same as this, but like uh, the condition is different. So actually, you can generalize this. So if the condition is not satisfied, remove something. If the condition is satisfied, add something. And you can solve counting number of segments kind of problem. Maybe we can discuss another problem as well. Wait, I can see right here. Wait, someone added a question. Okay, so maybe we can think about more classical problem here. So, okay, you've given us string which consists of lowercase letters. So, and you had to find the largest substring which don't have any duplicate letters inside. That means like you have to find a unique, you have to find a largest substring which contain unique letters. Can you solve it using 2 pointers? Yes, we can solve it. So how we can solve it is like the exact same thing, but here instead of adding, instead of subtracting, we can maintain enough array to check whether we can create a frequency kind of table and check whether the character is already exist or not. If character is exist, then that means it's not a valid uh, sub-array and you can move the left pointer. Otherwise, you can move the right pointer and so on. So those kind of problems can be solved using sliding window technique. Okay, I hope you guys are clear about 2 pointers. Do anyone have any questions? Hello. Anyone have any questions? Okay. Uh, is it clear? Can someone put a message? Clear. Maybe we can discuss some advanced stuff in the next session where we discuss problems and all. Over there, we can discuss some advanced 2 pointer thing. Okay. Let's move on to the next thing. Prefix sums. It's also one of the main technique that is used in problem solving. Like if you look at like 10 problems, you can see at least one problem that uses prefix sum. Even though there are like many other advanced data structure and all, people use prefix sum because like it's very easy and very convenient, and like you can do lots of stuff with prefix sums. Okay, so what is prefix sum? So prefix sum means like you will get the sum from the beginning. So if you're at ith point, that means the ith point ith point have sum from 0 to I, the sum of all the elements over from 0 to I. And if you want to calculate the sum of sub array, let's say you have to find the sum of sub array L and R, then you can simply say like prefix sum of R minus prefix sum of L minus 1 equal to prefix like the sum of the sub array, because like the prefix sum of R will contain a sum from 0 to R, and prefix sum of L minus 1 will contain sum of elements from 0 to L minus 1. So if you want to find the sum in between, you can just subtract prefix sum of R minus prefix sum of L minus 1. I mean, you can see it here clearly. So here you want to find the sum between 1 and 3. So it is like prefix sum of 3 minus prefix sum of 0, which leads to the sum between first and the third position. Even though it's a very simple technique, you can like do lots of things using it. So, okay, let's look at this first. So, prefix sum is not only for one dimension. You can create prefix sum for multiple dimension as well, or 2 dimensions, 3 dimensions, so on. But it's hard to implement. Like, I mean, you can try implementing 3 dimension as well, but like after that, it's very difficult. Okay, let's look at 2 dimension. Yeah. So let's look at this 2D array, 2D grid. What you can do here to get the prefix sum, to build a prefix array. So what you can do is you can like build a normal prefix array for all the rows, like build a prefix array for this row, build a prefix array for this row, build a prefix array for this row, likewise. Then you can just like this some how to say. Okay, so if you want to get this doc sum, what you have to do? You have to just add this sum plus this sum and this sum, right? Because like it will consist the sum all the way to here, and this row will contain the sum to here, and this row will contain the sum here. So what you can do is like for each column, you can like add the column above it, the sum from the column row above it. So here it's the original array. To build a prefix array for this, like we build the row wise first, then we just add the for each column we add the previous row's value to that column. Okay, is it clear? Is it clear? So what we does is like we build prefix sum all the way like in this direction first, likewise. Then at this portion we like build a prefix array this direction as well. So the sum for this box will contain here. The sum for this box will be contained here, likewise. And to get the sum of this block, like let's say you had to find sum for some block inside the grid, what you can actually do is uh, get the sum of this block, then subtract this one and subtract this one and add this one. What exactly is you have to like if you get this value, it uh, will contain all the sum from here, right? You have to subtract this block and this block, which the sum of this block will be contained here. The sum of this block will be contained here. But one thing you can notice is like this block is taken twice into account. So you have to add this value to get the sum, exact sum. Yeah. So that is what sorry we are doing here. To get the sum of this block, we are adding this block and we are subtracting the sum from we're subtracting 23 and 6. So what's the sum of this block? 18, 28, 31, 32, 30, 38, right? So this is the prefix array we built. And the sum will be 65 minus 23 minus 6 plus 1, which is equal to 38. So it's correct. Mhm. Actually, 37. Yeah, 37. Yeah, it's correct. Do you have any questions up to now? Hello, you can put it in the text chat box. Any questions? Is it clear? Clear up to here. Okay. Okay, great. So that is prefix sum. Okay. So where the prefix sum can be helpful, and what else we can do using prefix array. Okay. So prefix array not only for prefix sums, you can do several other operations as well. Like you can do any invertible operations using prefix array. To be precise, like you can do addition, subtraction, multiplication, maybe XOR operations, because like it won't change the value in between. Like if you take the normal prefix array, let's say we are going to use XOR operation here, it still satisfies this condition. Like if you want to get the XOR from 1 to 3, the XOR of first 3 element XOR the first 1 element. So let's say P of 3 contains XOR from 1, 0 to all the way to 3, and prefix of 1 contain XOR from prefix of 0 from XOR of 0. So if you XOR these two, the answer won't there won't be any other different value you will get, because if you XOR it, this and this will be cancelled out, right? That is what XOR operation is, right? Those are invertible operations, which you can do. Maybe multiplication exceeds the integer limit, then that's a problem. But other than that, you can do it. What is? Okay. What? There's another thing you can use. You can use it in prefix sum array. What is you can build a. Okay. Let's see a problem like this. You're given. Okay. You're given a set of operation set of operation you have to change you can add value x to some segment, or value subtract value y from some segment. Okay, for that, but you can it code difference array. Okay, let me show you. Okay, you given some operation, you can change you can add some value x to some sub array, or you can subtract some x from some sub array. Without prefix array, what we can do is we will iterate all over the element and add x or subtract x. But using prefix array, what you can do is you can maintain another array called difference array or something else, some other name. So let's say you're going to add 5 to sub array from 1 to 5. In normal way, what you would do is go from 1 to 5, 1 at 5, 2 at 5, 3 at 5, 4 at 5, 5 at 5. But here, instead of doing that, you can add uh, 5 to the first, the starting index, and you can subtract sorry, it's not clear, the handwriting. You can subtract 5 from the right plus 1 point. And if you do a prefix sum from in this array, what you can see is at last only the subarray from 1 to 5 will have this plus 5. From 6 onwards, there won't be a plus 5 because we are subtracting, right? So using this technique, you can do range operations as well. What else we can do using prefix sum array? We can use the idea of 2 dimensions here. Okay, let's say you have a problem where you had to store how many lowercase, for example, they given there's Q queries, and you had to find how many ABCs are in between that segment. For those kind of problems, what you can do is you can build a 2D prefix array and use it as a frequency table. So up to ith point, what are the letters we have. Using that idea, like you can get what are the lowercase letters in between those 2 points, I and J. So that can be done using prefix sums. Okay, let's look at some real world applications using 2 pointers and prefix sum. Like you can use both 2 pointer and prefix sum and solve many different kind of problems, which like both are very strong techniques. So if you see a real world application, okay, let's say you're building a banking application. So customer wants um okay, so customer wants to find a, a 30-day gap where he spent the most amount of money. What you can do is you can just simply use 2 pointer and prefix sum and check all the 30-point gap uh, transactions and see like which uh, have the maximum amount, in which gap the maximum amount of transaction happened. That can be checked. Or else like if you can give a option to customer where he can uh, uh, yeah, he can like add amount and see like how many different segment, like how many different times of period he spent that amount of money. Or you can give option like what is the minimum gap he spent X amount of money. So for example, like he wants to know what is the minimum gap period he spent 1 lakh. So for those kind of problems, you can use 2 pointer and prefix sum, like prefix sum to get the sum between I and J, the left pointer and right pointer. And if the condition satisfied, you can move the pointers and find the values. Likewise. So yeah, so when you're building applications or software or anything, instead of using two loops, two for loops, actually, or even a loop, you can use these pointer like 2 pointers and prefix sum and optimize a lot, because like prefix sum operation is O1. Instead of ON, you can do it in O1. And 2 pointers, instead of using two loops, which is n squared, you can do it in one loop, which reduces a lot. Because like let's say per day, like if you take a bank thing, how many operations they do? Maybe 500,000 operation per day. I don't know. I'm not sure. Let's assume that they do 500,000 operation per day. So you can obviously see the difference, right, between n squared and n. It will like use 2 pointer and prefix sum. And these are good resources if you want to learn about 2 pointers and prefix sums. Yeah, that's all. Let me check again if I didn't cover anything. Mhm. Yeah, I think I covered it, covered all the basic stuff here. Maybe we'll check more advanced and different techniques of 2 pointers and prefix sum in maybe next session where we solve problems. And do we have any questions? And by the way, like after this session, I will add some problems to your group. Uh, maybe you guys can add your own questions as well. So I'll solve and maybe we can discuss in the next session. We can do that. Yeah. So do you have any questions? Didn't you any point you didn't understand or anything not clear? Hmm? Can we have a recording? Yeah, can have the recording, I guess. Any questions related to 2 pointers and prefix sums? Mm, mm. By the way, I made a simple Kahoot uh, thing which consists of 5 interesting questions. I say maybe try and see. I added the link to the chat. We try and see. Start it. In the meantime, you can ask any questions if you have. If something not clear, you can ask. If you have any problems, you can ask. So the correct answer is A less than or equal to R. For the Akshay in leading. That is correct. Still the Akshay is in leading. Wow, nice. Dakshani first. Someone named Hi second, and someone named Pom came third. That's good. Good job. So, do you guys have any questions or anything not clear? Just ask any question. It's fine. It's fine. We can discuss. No questions?
Thank you, Mr. Apiram, for that structured and informative session. You've helped break down complex concepts into digestible strategies that we can start applying right away. And again, we would like to open the floor for a brief Q&A session. If you have any questions about the concepts discussed or competitive programming in general, feel free to drop them in the chat. We'll leave the questions floor open for another minute or two, so please be kind enough to forward the questions to the chat box.
Wait, there's a question. What are the most important technique do you use for competitive programming? I mean, two pointers and prefix sums is very useful as well. Maybe recently I found out the square root decomposition is quite useful. Like there are a bunch of advanced techniques maybe you will learn in coming series. I mean, every technique is very useful. If you can use two pointers very well, you can show like at least you can get partial marks for most of the problems. So every technique is very useful. I hope the answer is clear. Nice. Any other questions?
Thank you once again, Mr. Apiram. Your explanations were not only clear, but practical and relevant for our audience, and your passion for teaching was truly evident throughout the session. We are grateful to have had you with us, and we are confident that today's participants are walking away with stronger problem-solving foundations. On behalf of the IEEE CodeX Sri Lanka team, we'd like to present you with this token of appreciation. Thank you for being a valuable part of our journey and for investing your time and expertise into developing the next generation of programmers.
Thank you. Thank you for inviting me.
Looking ahead, we've got another session coming up this week on the 12th of July. These sessions will build directly on what we've learned so far and include hands-on experience to sharpen your problem-solving abilities. So be sure to mark your calendars because you do not want to miss them. If you haven't registered yet for the IEEE CodeX Sri Lanka Session Series, head over to our official website where you can learn more about the competition, track your progress, and get to know updates about the sessions. Scan the QR code now shown on the screen and register yourself to get full access in the IEEE CodeX Sri Lanka official website. You can join our WhatsApp and Discord groups where you can receive important updates and stay in touch with other participants. Our QR codes are now on the screen, so feel free to scan and join. And with that, we conclude today's session. Thank you for joining us and actively being a part of this. Each session takes you one step closer to becoming the confident problem solver you want to be. We hope you found today's discussion both practical and inspiring. We'll see you again very soon in the upcoming sessions as we continue to unlock new techniques together. Until then, stay curious, stay consistent, and keep challenging yourself. Good night, everyone, and thank you once again.